12, I guess, in yours. Is it page 12? Anyway, stoichiometry. Basically, you're converting something, whether it's mass, molecule, volume, into moles, because moles are like the crux of chemistry. We crossed the moles bridge. I hate this diagram, by the way, but it's in here, so we might as well talk about it. To get moles of whatever other chemical you're talking about, and then you can convert that into volume, grams, whatever. To do any of this, you need a balanced chemical reaction. If you don't have a balanced chemical reaction, you can't do stoichiometry. Or, well, you can't do it correctly anyway. So, this is a combustion reaction. How do you know it's combustion? Yeah. Hydrocarbon plus oxygen produces CO2. It's balanced, so that makes it nice. What mass of CO2 is produced by reacting 2 moles of oxygen? So what you're given or what you're... 2 moles of O2. So this is where I think, like it's up to you, but always, in my opinion, always write what you're talking about, because we're going to switch the molecules halfway through, or the substance we're talking about. So we have 2 moles of oxygen. I want to figure out how much CO2. So I need the mole ratio from the equation. I know that for every 5 moles of oxygen used, I produce 3 moles of carbon dioxide. 5 moles of oxygen goes in the denominator because you want the units to cancel. Gives me 3 moles of CO2. So moles of oxygen are now gone. The units we have left are moles of CO2, but I don't want moles of CO2. What do I want? Mass. To figure out the mass, I need the molar mass. What's the molar mass of carbon dioxide? 44. Carbon dioxide is 44 grams per mole of CO2. Cancel, cancel. Everything in the numerator gets multiplied, and then you divide by the stuff that's in the denominator. So what is your answer? I actually want you to do this, please. How many sig figs should we have? 3. How many grams of CO2 do we produce? 52.8? Is that what we said? Yeah. All right. 52.8 grams of CO2. That's stoichiometry. Every question is kind of the same thing. What mass of C3H8? What's C3H8? 3 carbon hydrocarbon. What is it? Propane. All right. C3H8. We have 100 grams of water. I don't want grams of water. You got to have moles. What's the molarity or the molarity? What's the molar mass of water? 18. So 18 grams of water is 1 mole of water. Then what do? I've got moles of water. I'm trying to figure out how much propane. Cancel out the, sorry, that again. Yeah, but I want to use like the molar ratio, right? Yeah. So I'm going to use the molar ratio from the equation, which is, where's water? 4 moles of water are produced for every mole of propane. So 4 moles of water for every 1 mole of propane. Whoa. And then what's the mass of propane? What's carbon weigh? 12. We got 3 of them, so that's 36 plus 8 hydrogens. 44? Yeah, 44. And then everything, all your units cancel, except for grams of hydrocarbon, which gives me how many sig figs? 4? Is it 4? How'd you get your molar mass? Which is 3. The molar mass is from the periodic table, which yours has 3, so it should be 3. 61.1 grams. Is that what we got? Yeah. All right. Okay. You want to try C? And then we'll see. Oh, sorry. In A, you mean? You're talking about A?
So you take your ratio of 3 to 5.
Yeah.
Find how far to do that, find 2 by 2 by 5, find 3 by 2 by 5 small. That gives you the number of moles in your fragments.
You can do that. But if they're big and long, and we're going back and forth, it might be a little tricky. But for something like that, where you're given moles here, so it's pretty like they're giving you the first. They've done this first step for you, right? So yeah, if you know the molar ratio, it's just a what's the word I'm looking for? A ratio question, for lack of a better term. All right, C, please. 50 liters of CO2 is what we want to produce. What are you doing?
My phone died.
What's the answer? 53.6. Okay. Do you have this titration question in yours? Okay. Unfortunately. Okay. We do titration. 3 runs of it. Remember titrations from Chem 11? We use those big long tubes at the back over there in the corner, and you dribble them down, and you probably had phenolphthalein, and it turns pink or light pink. Remember doing that? Okay. We do 3 times. We get 22.8, 22.1, and 22.2 is how much of a 0.2 molar barium hydroxide solution is required to neutralize 10 mils of HCl. What's the concentration of HCl? What's the first thing we should do? Before you can do a Stoich question, what do you need? You need a balanced equation. All right? We don't have a balance. We don't even have an equation. So we got to figure out what we're doing. We're reacting barium hydroxide with hydrochloric acid. What type of reaction is that? Neutralization. When you do a neutralization, what's one of the products? What's the easy, simple product that you always get? You always get water and a salt. And the salt is just the metal and the non-metal. So barium chloride. But what do you have to do with the equation? Balance it. Balanced. We got 4 hydrogens on the left, 4 hydrogens on the right, 2 chlorines, 2 oxygen, 1 barium. Yep, we're good. Okay, so we got a balanced equation. Now let's look at the numbers. I don't know if they talked about this in math or in Chem 11. 22.8, 22.1, and 22.2. Why is the first one bigger? I mean, these aren't large numbers, but it's bigger by a significant amount. Not precise. When you do you remember doing titrations? What's the first thing, the first run? What do? You get an idea. Yeah. Remember the first time you do it, you like crank it and you go really fast just so you get close to the equivalence point, knowing when it's going to change. We're going to do it again this year. But anyway, that's why the first one is off. Okay? You don't fake your data. You still have to record it, but what do you do with it when you're doing your calculations? Do you use it? No, you don't use it. So you still have to record it. You have to record all your data for future reference. Okay? But why am I writing this? We're going to ignore that one. Okay? So what's the average volume that we used? 22.15. Okay. Ideally, what you would do is you'd probably do another run to see if it's close to 21.1 or 2 again. But 22.15, I just average those two. Okay. That's what we're given. That's the amount that you know. So we want to convert that to liters. What's 22.15 in terms of liters? So that's how many liters of barium hydroxide we used. Okay. We know the concentration of barium hydroxide is 0.2 molar. So what am I trying to figure out? The moles of barium hydroxide. Molarity is moles per liter. I know the molarity is 0.2. Equals moles divided by liters. So how do you get the moles? Multiply the volume up. You can convert to scientific notation if you want. Okay, so we have 0.00443 moles of barium hydroxide. How do I calculate how much HCl I have? Use the equation. That's how many moles of barium hydroxide I have. What's the mole ratio here? It's 1 to 2. So for every mole of barium hydroxide, I react with 2 moles of HCl. Which gives me 0.00886 moles of HCl. What are they asking? What's the concentration? And I have 10 mils. So what do I do to get the concentration of HCl? Divided by the volume. So if I take this and I divide by the volume, which is 0.0100 liters, it should move it over by 2, and it should be 8.6. I mean. Did I do that right? No, I didn't. 0.8. 886, which would round to what? Oh, we can leave it like that. 0.886 molar. Okay? So, write your equation. Figure out if you have 3 trials, if there's one that is way off, exclude it, average them to get your volume, calculate the moles of whatever you were adding, whether it's the acid or the base, use that and the equation to calculate the mole ratio, divide by the volume to get the concentration. Okay? Yep.
Can you only use the M times V equals N times V formula when they're the same thing?
Are you talking about dilutions? You talking about this one?
Yeah.
This is a dilution formula. Like if you have a certain concentration and you're adding more liquid to it to dilute it, or you're mixing, like in that one that we did, mixing 2 different concentrations together. Okay, so that's changing the concentration. This, I'm not changing the concentration. I'm trying to figure out how much there was. All right. So in the question to use this M1V1, it will probably say something like 2.5 molar of whatever is diluted to blah. And as soon as you see diluted, that's the formula you use. Okay? Or mixed. It could say mixed as well. How many questions? 4 questions on the back, and then we'll do solubility, and then we are done, peoples. All right, as soon as you see the word solubility and they're asking you whether it's soluble or not, you're going to go to your data booklet. You're going to go to this fun page that will tell you all the solubility. We do a whole unit in Chem 12 around solubility that's a little more involved than this, but for now we're just going to say soluble, which means what? If I say something's soluble, what does it do? It dissolves, yes. If it's not soluble or low solubility, it doesn't dissolve, okay? So if we look at first one, potassium sulfite, SO3. Go to your data booklet. Boom. First of all, anything that has an alkali metal in it is soluble. All right. So if you see a compound with an alkali metal, it's soluble. Okay. You don't even have to look at the other stuff. But if you look at sulfite, SO3, is SO3 even on here? At the bottom, there it is there. With the alkalis, it is soluble. Okay. So you can put a big S, soluble. All right. Ammonium sulfide. So find the ammonium group, or you can find the sulfide group. There's a sulfide group right there. Boom. Ammonium is up top. The top ones are soluble. So it is also soluble. Another big S. Okay. So in a sec, I'll get you to go through and tell me if those are soluble or not, but I want to do one of the reaction ones. So let's go to the bottom here. I'll just do one and then I'll let you do the rest. So this is going to involve everything. Aqueous magnesium, we're going to do A here. Aqueous magnesium chloride reacts with aqueous silver nitrate to produce magnesium nitrate and silver chloride. We want to write a balanced reaction, and then we want the states. And by states, I mean solid, liquid, gas, or aqueous. Okay? So, magnesium chloride is MgCl2. It's aqueous, which means it's dissolved in water. So we put a little AQ there. We react that with aqueous silver nitrate. What's the charge on silver? Uno? Nitrate is NO3 or NO2? You can always look on your chart. I'm just quizzing you. NO3. It's NO3. So that's silver nitrate, and we're aqueous again. What type of reaction is this? Double replacement. So the metals basically switch. We're going to get silver chloride and magnesium nitrate. So silver chloride is AgCl, and magnesium nitrate, MgNO3 2. Okay. Notice I did not put the states there. Why did I not put the states? You don't know what? I don't know what they are. That is true. But what happens if you... Yes. One of them might not be soluble. So you go back to your data page. Data booklet. Nitrates. Where's the nitrates on here? Nitrates right here. As soon as you see a nitrate, boom. They are soluble with everything. Doesn't matter what they're bonded to. Okay? So anything with a nitrate, just like an alkali metal, is always soluble. So that is going to be aqueous. Okay. AgCl. It's going to be low. There it is right there. So we find the chloride. Look down here. It's with silver down there, which means it's low solubility. If we're low solubility, we form a what in solution? A solid, which is called a precipitate. So we go solid. I usually abbreviate precipitate, PPT. Just means it falls out of solution. Okay? Sits on the bottom. What? Are we done? You know when I ask that, it's not. You have to balance it, right? Every equation needs to be balanced. So if we put a 2 there and a 2 there, we're good. Okay? Any questions? All right, I want you to do B and C and tell me, you just have to write soluble or not soluble for those things there. And then Chem 11 review is over. Everything in this package is fair game for your group quiz tomorrow.